lot of me today. It's more I2C time. So I've shown you the actual protocol of how I2C works. I wanted to show you the software that I use to do that demonstration to grab those waveforms, okay? So here is my desktop. There we go. Bada bing, bada boom. Nothing important in the bottom left-hand corner anyway. So I'll just cover that right up with my mug. All right, in this project here, I have my top design. I'm using PSoC Creator. You can use any micro you want, really. Almost all of them have I2C. Here I've declared that I'm using an I2C using their serial communication block, right? So I've said, hey, that's why it says component name is SCB, right? Serial communication block. I've got a sensor net. I've named it I2C sensor net, and I've got debug UART. I've got an interrupt pin that I'm not using just yet. None of those are really important. I'm just using I2C is what I'm saying. I guess the thing that's worth noting is that I am in master mode, and I've set it to 50 kilobits per second. I was having some finicky behavior at 100. I mentioned before in my other video that I'm using some big loop wires. 100 kilohertz was just killing it. It wasn't going to work out, so I scaled it back to 50 kilohertz. I think that's the lowest you can go, I think. All right, so here we have, in my projects, I always have this stuff that's like set debug modes, and I have run modes, right? So right now I have a run mode of I can do a write operation or I can do a read operation, and that's how I wrote this software. These are all pound defines, so what I'll do is I'll do a pound define if, and then debug mode equals serial mode. All serial mode would do is tests my serial data software. It's a different thing, don't worry about it. But the run mode is the important one, because I'm in I2C write operation mode, which is defined as just number 2. It's just an enumeration so that I can say, hey, if run mode equals I2C write operation, then do all this stuff. And here in the code, you have commented out some code that I don't use anymore. Boop, boop. Oh, I'm in the middle of debugging, so it didn't want to let me edit it. Let me just edit it now. All right, that's going to go. That's going to go. Yeah, it's got to go. Make that go away. Goodbye. All right. And I don't have a stop condition. That's why the other video didn't have a stop condition on my right. Bugs, bugs, bugs everywhere. Okay. Here I have pulled from the data sheet, the order of operations. It says start. What's your slave address plus the write bit? Slave's going to ACK. If I put a / here, that means it's from the slave. Then master's going to say register address. Slave ACKs again. We're going to... Oh, this is for the read op. Yeah, this is not right. I got these mixed up. Yep. Get some real-time live comment fixing. It's not really a bug. It's just my comments suck and are inaccurate. All right, so here we go. All it's doing when it's doing a write operation is it's going to send its start. The start condition includes the address of the slave. It's also going to say that I'm in write mode. This is just a macro. That's all it is. All it means is 0 is what that's really saying. Then we're going to go ahead and write the address, the control register, which is 1B. And then we're going to write the value I want to put in the control register. And that's a bunch of 1s and 0s. Okay. And this just puts in the high resolution mode for this accelerometer. And then I will go ahead and print out to the debug UART everything I just did. So if I were to pull up the waveform here, so that's, that always gets me. This is the write operation. You see the write operation is the top one here. Start, slave address plus write, ACK. So here's the ACK, register address, ACK again, and then the data, then an ACK, and then P, which is a stop. And you can see all those conditions down here as well. All right. For the write, if I were to go ahead and put this into read mode. Okay. Now we got a new set of pound defines that are active. You see that we're doing the more complicated thing, right? We're gonna first write to it the register address, then we're going to restart, and then we're going to request a read, and then it's just going to spit out the data that's at that read address. You can see here the send start, with the slave address and the write mode, right? So that's this guy here. You've got the I2C master write byte. So I'm going to send now the register address right here. All the acts are coming from the slave, so I don't have code for the acts. Those are all from the slave. So the master doesn't need to worry about that. Master just needs to confirm that that's happening. And that's built into these routines. So I2C master send restart, that's this guy right here. And it comes with the address again. And now we're in read mode. Okay, so that's read mode right there. Again, we got an ACK. And then here we're going to read a byte. And this is telling it to not acknowledge the data read once it's done reading the byte. And we're going to store that data in this read byte variable, which is a 100 element buffer. It's just any number of elements. I tried just making it a regular pointer, and the software got really mad at me. And then we spit all that stuff out over TerraTerm. I wonder if I left TerraTerm on. So yeah, you can see a little bit. You know, here's the address I'm sending to. There's the register value, the register address 1B, and I sent it an F8, right? So that's it. That's how the software works. It's pretty simple. I'm doing this in byte mode because I don't need to send a whole string to the device. You could send it in a string of one element, but that just seems a little strange to me. So I like to keep it low level. I'm a low level kind of guy. All right. So I'll see you guys next time. Have a good one. Bye.